Hello dear students, welcome back for the next experiment. So I am Dhanashri Naiknore madam from the JSPM Imperial College of Engineering and Research Vagoli, and today we are going to discuss the experiment which is related to the LED. So as you can see the GIF here, so LED is on and LED is off. So what is the logic behind this? We have to pass logic 1, then LED will glow, then we have to stay at that position for some time, and after that again we have to off that LED. So in between on and off we have to provide some delay so that we can analyze or observe the blinking of LED. Now that LED I am going to show you the LED interfacing by using the Proteus, again by the simulation software. So let's see. So LED interfacing is very simple. LED is nothing but a light emitting diode, and that we need to interface with 89C51. Okay, so light emitting diode, this is the simple connection having the anode and cathode terminal. One connection we have to put it as a ground, and one connection we are going to connect it to the 8051, that is our 89C51 IC. So the write an assembly language program to flash, that is to blink LEDs connected to port considering a time delay. Now I have explained you that we can connect the LEDs. So single LED I have shown you. Here we have to connect all the LEDs to port, any port 0, port 1, and we have to glow all the LEDs at the same time, and we have to off all the LEDs at the same time, so that the sequence or series of LEDs will be on and sequence of series is going to be off. So for that purpose we require to start the address location and then turn on the LED. Now turn on LED means what? We have to just give logic 1 to the port. So let's consider if I am going to connect all the LEDs from port 1. So for that port 1 I have to first pass all ones. So FF value I have to load, LED will on. Now for that situation, or for that on condition, in that on condition we have to stay at some time, that's why I will call delay, and then again I have to turn off the LED. So basically if I am passing 1 for the on, then I will pass 0 for the off. So when I pass this, that is a 0 value, if I load into that port, then what will happen? LED will off. Again I have to stay at that condition for some time, so again I will call delay. And if I want to do this process again and again, then I will use go to instruction, and then I will jump to the start again and again. This process is going to be continue. So once we are going to do this, so we will get a beautiful output of LED on and off, that is LED blinking. So let's consider what logic we are using in the program. So as I have told you, this is the starting, then I have to load first 0 value for off, and then delay, then FF value for on, and then delay. Now this delay subroutine, all of you know that this delay routine we have used, that is 3 registers value. In that we are going to load some values, and then we are going to decrement one by one register, so that what will happen, the delay will be provided up to that time duration to execute this instruction. So very simple program we are going to see. Only we need to load once 0, and in next condition we have to load 1. So 0 and 1, that only you have to load. So if you are going to connect only single LED, then you can load the value in single bit, or you can load the whole value as like this. Okay, so now I will show you how we can do this LED interfacing by simulation. So we'll go into the Proteus software again. Okay, so once you go into the Proteus software, as I have already explained you, so you will get this window, and in that window you have to take the component. So we required IC, that is 89C51, 8089C Atmel IC. Then we required LEDs, right? LEDs means light emitting diode. So first we'll take IC, that is 8089C51. So this is the IC. Adjust this on the screen, then take LED. So there are different kind of LED we have. You can take any from that. So I will take yellow LED. So once you get the output, then yellow light you can see as a output on the LED, in the LED. So you can take multiple copies. As we have to connect 8, first I will show you the demonstration of 3, and once we get output for 3 LEDs, then I will connect the another LEDs. So adjust that LED. So I will just do this so that it will be easy for the connection purpose. As I have already told you in last session also, that overlapping should not be occur in wiring while doing the connection. So I have written the code for port 1. So I need to connect all the LEDs on port 1. If you want the description of that component, then you can click on that. You will get a description, what are the different parameters are there related to that particular component. So connect the LEDs. I will doing the connection. So at port 1.0 I have connected one LED. See, you can see in zoom in version. So pin P1.0, that is port 1 0 bit. There I have connected D1, that is the first LED, then second LED, and P1.2 third LED. Now to prevent the LEDs, I will connect register. So we'll take another component from the library. So whatever devices or whatever component you want, you can easily get that component through the library of Proteus. So remember one thing, that if you want to explore this software, then you have to download different libraries from the net, and you have to include all that libraries into this Proteus software. So once you include all the libraries, so you can get all the devices, component, ICs like this. So we require 3 register. So 3 register I am going to connect, and then we require one ground to ground this all the cathode terminals of the LEDs. Okay, I require now ground. So I will take it ground. So ground this all the cathode terminals. Okay, now connection is over. So we can simulate that. So before simulation, what we required? Hex file. So we generate a hex file of our program. So we have to go into the Keil version, create one new project, give some name. So you have to create one folder, and in that folder you can create a project. So always we have to follow the standard procedure so that there will be no any confliction between the files, because we are doing a lot of programs, so a lot of files are there. So you have to take care about that. So flash. So I will give the name, that is flashing of LED, that means blinking of LED. So flash LED. So select the IC. So as I have told you, we have taken 8089C51. So we have to select that IC. So 8089C51, that IC we need to select. Now we are going to copy our program, whatever program I have explained you in PPT, that program I will take and I will copy that into this Keil version 5. Okay, so this program I have explained, simple program of LED. So I will copy paste that program in the Keil. Now we have to save this file with the extension .asm. So I will save this file. Save as. We have to give the extension as a .asm. .asm. Now save this file. So you can observe the color combination will going to be changed. So see, so now we have to add this file into the source group. We have to add this file into the source group, and then we have to create a hex file. Just click on add and close that window. So if you click on source group, you will get this file. Now you have to create a hex file. For that, right click on target, output, create a hex file, and then OK. Now our hex file is created. We need to check the errors are there in the code or not. So build, no error, 0 warnings. Again rebuild, again there is no any error, no warnings. Then you can translate that program. Translate. So you will get an hex file where you have created this project. So in that folder you will get a hex file, and that hex file we required for the simulation purpose. So we are going to go into the click on IC and browse the file. So flash LED, this is our hex file that we have to browse. LED folder, in that object folder, in that flash LED. Yes. Now hex file is loaded into the IC. Now we need to just observe the simulation. So hex file is loaded into the IC. Now once I play button, then I will get the output. Now here I am not getting output because of the register values. So what I need to do, I need to change that. So I will stop the simulation and I will change the value, and then I will again simulate that. So we need to change this because this value is, for that value we are not getting output. So we need to change the value. So change the value for all the register so that you can observe the output. Okay, now this is done. Now we'll get output. Now press play button. See, so I have taken yellow LED, that's why yellow light is going to be blink. So in this way I have successfully connected 3 LEDs with a 8089C51 IC. Now see, in a similar manner you can directly connect 8 LEDs. So I will directly show you the output of 8 LEDs. As you know the process, this is very simple and connections are also very simple. So see, we are getting such a beautiful output of LED series. So LED is blinking, and that is on and off. So this is the zoom in version of the output. Hope all of you understood this practical. Thank you.